All right, we're on Module 7, Lesson 1, page 2. We have the last two to do on that page. So we had just finished with this one. It was a horizontal line, which means the level did not change. So there is 0 rate of change when it doesn't change. So that's 0 meters per day for the water level. Looking back at the graph, describe what is happening to the height of the water from day 6 to day 8. So day 6 is here, day 8 is here. So it looks like it's going from 10 to 20, right? 10 to 20 in 2 days. And it's going up. That means my rate of change will be positive. Remember, this one was going down. The rate of change was negative. When a line falls, it's negative. When a line rises, the slope or rate of change is positive. When the line's horizontal, remember, that means 0 rate of change. It's not changing. So this is going to be positive, and it went up positive 20 meters in 2 days. So positive 20 meters in 2 days. But as we said in problem 6 above, when we're doing rate, we don't want to know how far we went in 3 hours. We want to know our speed per hour. Likewise, that's what this be specific means. They want to know how much is it increasing per day. So to make that 1, I would have to divide both of these by 2. And as you probably guessed, that means it's 10 meters per 1 day. So then we do the same thing we did above and we write a sentence. This time we would say increasing or going up 10 meters per day. So let's use increasing. That's a little bit nicer word than going up, going down. So the height of the water is increasing by 10 meters per day. So see the word per? Every time we're asked to write about or describe rate of change, we have to use the word per, and we want it per 1 unit. So per dollar, per day, per hour. So we want this to be 1 unit. It started as 2, but when we divided by 2, we turned it into a 1 unit of time. And then the last from day 6 to day, same problem. I thought we had to look again. The rate of change of the height of the tree, and remember, rate of change, ROC, is really just slope. So we're telling the reader what the slope of that line is. Rate of change and slope are the same thing. So it would be positive 10 meters per day. That means the line should be rising, just like up here when it was negative, the line was falling. 10 meters per day, as we said above. Okay, let's go ahead and look at page 3. So that was our little introduction to rate of change. Page 3, we have a candy shop going on. So at Caldwell's Candy Shop, customers can purchase 4 pounds of candy for $3. So you can see here in the table, 4 pounds, $3. And 8 pounds of candy for $6. So 8 pounds, $6. Or 12 pounds of candy for $9. 12 pounds, $9. Use this price structure to fill in the missing values in the table. So sometimes it's easier if we answer this first question, because don't we want to know what the rate of change is? Rate of change, remember, will be the cost per pound. Don't we want to know the cost per pound? It's always Y per X when we do rate of change. And the reason why, if you remember back from Module 6, we learned this was a slope formula. Second y minus the first y over the second x minus the first x. Remember that doing that in one of our modules? So the reason it's y per x is because that's the slope formula. The change in y's, division is read per the change in x. So when we go to write the label, it's always whatever's in the y column, because remember, this is your x, this is your y. Whatever's in the y column, dollars, then we use the word per, and whatever's in the x column, pounds of candy. So dollars per pound of candy. That's what we want to know. What does 1 pound of candy cost? After we figure that out, we can do all the problems. And that's what rate of change gives us. It gives us the cost per pound. Or you could say dollars per pound, whatever. But that's what it's going to give us. Y per X. Cost per pound. And that means what's the cost of 1 pound. Once we get that, like I said, all we have to do is multiply. So the rate of change, let's go ahead and write 2 ordered pairs here. Let's write 4, 3, and 8, 6. And always about this time, I have students going, well, how did you know which 2 to pick? I just picked the 2 that were the smallest numbers. We only have 3 points. So I could have picked any 2, and I'm going to get the same answer on the next step. So when they say rate of change, I immediately think, oh, that's just slope. So that's what made me do this, because some of you may be going, how did she know to write 2 points? Because it asked for rate of change. I know rate of change is slope, and I know the slope formula is the second y minus the first y over the second x minus the first x, which means I need 2 points. So when we were doing this in Module 6, we called this x1, this y1, this x2, this y2. So our slope or rate of change is, and let's just put m there too, so you know they're the same thing, second y minus the first y over second x minus the first x. So that comes out to be 6 minus 3 is 3, 8 minus 4 is 4. So think about that. I'm going to shut my door. My dog's snoring. Okay, so this is cost per pound. Well, we usually don't say 3/4 of a dollar. What would be a better way to write 3/4 of a dollar? If you don't know, do 3 divided by 4 on your calculator and you see it's 0.75. Doesn't that make more sense since we're doing the cost per pound? We don't want to say 3/4 of a dollar per pound. It's better to say it's 75 cents per pound. So rate of change equals 75 cents per, because rate of change always has the per in, and it's always y per x. So we have to go backwards on slope because it starts with y's. So cost per pound. Now we can use that answer to help us with this, because that's what I would have done if they hadn't asked that, is I would have found the slope, because I want to know how much 1 pound costs. So just like we were doing with the water in the previous problem, we found out what happened in 1 day. This is finding out what 1 pound costs. So now we can fill in the table. So we know that 75 cents per pound, that means 1 pound is 75 cents. So how would I find the cost for 3 pounds? 75 cents times 3, right? So let's get our calculators out. I think that's 225, but 0.75 times 3. Yep, $2.25. Oops. So that would be 225. And you can do 0.75 times 4. You'll see it's 3. You can do 0.75 times 8. You'll see it's 6. So the next one we need to do is 0.75 times 10. And when you multiply by 10, that just moves the decimal place over 1. So that would be $7.50. And remember, money always has to be 2 decimal places. So when your calculator gives you 7.5, this is money. So make sure you have 2 decimal places. And then we have this one. We multiplied to go from column 1 to column 2. So what do you think we're going to do to go from column 2 to column 1? What's the opposite of multiply? Divide. So we're going to do 22 divided by 75 cents because we're trying to see how many pounds of candy there are. So divide $22 by 75 cents, and that should give you how many pounds there are. So $22 divided by 0.75. Ooh. Oh, Kim did it wrong. So look at this. I don't want to have to type it again, so I can hit my up arrow, and I can change that to the 0 and that to the plus. Just type over the top. There we go. So 29.33333. What is that as a fraction? 3333333. Anybody know? 1/3. So if you didn't know, your calculator will tell you. So we want to go fraction. Well, actually, we want to go decimal to fraction. This is a double arrow. So we do second PRB, hit enter, boom, 1/3. So if you didn't know 0.33333 was 1/3, you can do second PRB because that says decimal to fraction. That's a double arrow there saying you can go fraction to decimal or decimal to fraction. I can hit it again and it'll take me back to the decimal form. Hit it again, it'll take me back to the fraction form. So it just toggles back and forth between the two. So 29 1/3 pounds goes right here. And don't write 29.3. We learned on our Module 5 test, 0.3 is not the same thing as 1/3 because 1/3 is 0.3333333. 0.3 is 0.3000000. So they're not the same thing. So you should write it as a fraction. Okay, so let's go ahead and see what the next question is. So in this situation, the rate of change is not an integer. That means like a whole number and its opposite, 5, -5, 7, -7. And it's not an integer, it's a decimal. Express the rate of change as a simplified fraction and explain its meaning. So we already know what it was as a simplified fraction. So rate of change equals, and let's just go ahead and write this work here just so we know where it came from. So the meaning, if we were going to leave it as a fraction, remember how these are the y's? So the y's are dollars, and these are the x's, pounds. So that means $3 will buy you 4 pounds of candy, or 4 pounds of candy costs $3. So y's are always on the top. So I took the label from the, y column. So y2 minus y1. So the label for the y column is dollars or cost. And This is x2 minus x1, so I took the label from the x column, pounds. So it's $3 for 4 pounds of candy, or 4 pounds of candy costs $3.